Hey, Accelerated Algebra, happy Friday. Today is more with radical equations, and one fun application that I hope you like. So this is about pendulums, and this is from your textbook, and it has to do with calculating the period of a pendulum. So that's the time it takes to complete a full swing. And I just want to kind of show you what I mean by that. So here's a video with some bunch of pendulums, and you can see that some of them, the small ones nearer to the back, are going back and forth a little bit quicker than the long one up at the front. So the ones in the back have a shorter period, and the one in the front has a longer period. Okay, so let's go back to our problem. So the giant swing completes a period in about 8 seconds. How long is the pendulum's arm? Okay, so 8 seconds, that's our t value. Okay, how are we going to solve this? This is just like what we practiced yesterday. We want to isolate that square root sign, so I'm going to divide both sides by 2 pi, and I can simplify. You finish that one, and then letter B says, does increasing the length increase or decrease the periods, the time it takes to go back and forth? So think about the equation and what intuition that might give you. Again, the equation looks like this. So if we make this larger, what will happen here to the time? So think about that in terms of the equation, and then watch that video and see what really happens. Going back to some of these equations that we practiced yesterday, remember that we're going to try to isolate the square root, square the entire side, entire expression on each side, and throw out any extraneous solutions. So for this one, of course, you want to isolate that square root first, and then I'm going to have you finish that one. You might have noticed yesterday that when we have variables on both sides, we often end with extraneous solutions, and that's going to happen here. This square root's already isolated, so I can go ahead and square both sides. Make sure on this side you get 3x minus 5, of course, but on this side you have to square the whole thing out. So remember, that's x minus 5 times x minus 5. So x squared minus 10x plus 25. Be sure that you set it all equal to 0, and then make sure that you factor and check for these extraneous solutions. Okay, I'll let you finish that one. This is a lot like number 5. So again, you're going to set equal to 0, factor, and then check your solutions. This one, same idea. I picked this one because one of our old friends comes back here, and maybe you're predicting what it is. That's right, this is a difference of squares. So you're going to factor and check your solutions. Okay, this challenge is a little bit of fun. So remember that we have to square the entire expression on both sides. Now, I can't really isolate the square root here. I can isolate it on this side, it already is, but on this side over here, no luck. So I'm going to go ahead and just square both sides. But I've got to be careful here. So this side, of course, is x plus 9. This side, I'm going to get the square root of 3 squared plus 2 times the square root of 3 times the square root of x, plus the square root of x squared, if I FOIL that all out. Simplifying here, I get 3 plus 2 root 3x plus x. Great, now if I just subtract 3 from both sides and subtract x from both sides, I end up with 6 equals 2 root 3x. So that means that 3 is root 3x. Square both sides, and I get x equals 3. Alright, we better go ahead and make sure that really works and check it out. They look exactly the same, but we've got to simplify here. The square root of 12 is the square root of 4 times the square root of 3. So 2 root 3 equals 2 root 3, and we're good. Your job today is to finish these ones that we got started together. They're also on page 644 of your textbook, and there will be a few problems on Schoology based on these problems that you did. Videos to check out. So if you wanted to kind of see that pendulum video, that's the second one listed here. And this one is really cool. It's listed on your daily agenda for today. We're going to talk about the Pythagorean theorem next week. And this is totally worth watching. Even if some of the math goes over your head, it has great intuition about why the Pythagorean theorem works and these things called Pythagorean triples and how they come up. So totally worth watching, I think. All right, have an awesome day.